All right, let's get started then. Kotlin code generation. So my name's Alec. I'm from Square.
My name's Jake. I work at Google. All right, so we're here to talk about code generation. And when we think of Kotlin, we like showing slides like this, where you have a swath of Java code, and Kotlin can replace it with 3 lines. We usually refer to this as boilerplate reduction. You can also think of the entire language of Kotlin as a code generator. It's a bytecode generator. It takes the syntax we write and turns it into Java bytecode. We tend to trivialize this as syntactic sugar, but really it's like operating on a higher level of abstraction, and that higher level of abstraction is a more optimal one because it's a better language. And so the majority of this talk, we're going to focus on Kotlin to Java bytecode, but we will address multi-platform stuff towards the end. So code generation, it's a bit of both for syntactic sugar and boilerplate reduction or even elimination. And you can go from a lot of formats to Kotlin code, or really any code. So you can have protocol buffers where you take a text-based schema of data and generate code that allows you to serialize it. You can have a language for your database and generate type-safe binders for actually executing those queries. You might have a representation of your API, the data that flows across it, and you generate the clients and the interfaces that you call in order to execute it. Or maybe you have a format that is not exactly easy to use in code, and so you generate something that allows you to bind to it. Or you have a platform-agnostic configuration files, and you want to generate type-safe static constants instead of reading and parsing YAML. If you're doing an annotation processor, maybe there's an abstraction on top of the types and elements that represent the code, and you can generate additional code that either implements interfaces or fulfills various contracts. If you're in an IDE, maybe you have a language-agnostic or language-specific AST that you can generate code from, but really it's irrelevant, right? There's whatever you can imagine you can use as a potential source for code generation. It really just comes down to the problem that you're trying to solve.
So one of the questions you might have is, why would you generate Kotlin code as opposed to something like Java? So usually when you're code generating, the thing you care most about is the API that you're exposing. And between Kotlin and Java, sometimes it's going to be similar. It's going to be hidden what the actual implementation is. They're only going to be dealing with the API. So to illustrate this, we're actually going to deep dive into one specific example, which is Wire. Wire is a library that Square writes, which takes protocol buffers and turns them into type-safe Java objects. So what a protocol buffer is, it looks like this little proto file. So here we're describing what an ogre looks like. There are 3 things for an ogre: a name, layers it has, and a swamp that it lives at. And there's already information here about the type, so required, optional, repeated, or telling you if it's nullable or a collection of some sort. So what Wire generates right now, the Java code, looks something like this. And you might immediately sort of realize that there are things here that could be done better by Kotlin. So one of the first things is that these properties, or in Java they're just fields, could be expressed much nicer as constructor properties. Additionally, these 2 separate constructors could actually become one if we use default values. You see in the first one, we're passing this byte string empty if we're not given a byte string for the unknown info. But there's also additional things that Kotlin gives us that we couldn't do before with Java. So you see in Wire right now, we're enforcing immutability on the list type at runtime. But with Kotlin, we can instead just expose a list, and then in Kotlin code, they won't be able to mutate that list type. Additionally, we lost some of that type safety around nullability from the proto file. So the swamp is supposed to be nullable in this case, but it's not. So again, we'll shift that into the Kotlin type constructor. So we'll take this Java class and instead turn it into the Kotlin class. And it's a lot more concise. It's a lot more readable. The API is almost the same, but there is one big difference, which is that if you're using it from Java, before you were just accessing a field, now you're using this bean method to get into the field. But if you've used this Kotlin before, then you know that there is a JVM field annotation that you can add to the property. And now the API is exactly the same as it was before. So especially if you're migrating your code gen from Java to Kotlin, this is something that you really have to keep in mind, that you're not going to be breaking people's code by introducing a different API. So this is just one of the tricks that you might run into for that.
So the next piece of generated code that Wire produces is turning these types into value types. So we have to implement equals hash code in toString, so they actually behave based on the value in the fields rather than as instance. And so here we have the Kotlin version of the equals hashcode and toString. But what we know is that a Kotlin data class allows us to take this and not have to specify it explicitly. So we can take the original class declaration, slap on the data modifier, and then suddenly we get those for free. But this actually doesn't work as defined. We have this unknown fields. Currently, it's just an argument to the constructor that we were passing to the supertype. And for a data class, this needs to be represented as a property, but doing so changes the semantics a bit of what's happening because it means that this field, which was just being passed to the supertype, now participates in the equals hashcode and toString where we might not want it to, and also it's present in things like the copy constructors, and we could potentially pull it out with the component methods. So we can do something like turn it into value, but again, this may change the semantics of what we're trying to achieve. And so one thing to keep in mind with code generation is that you're not subject to the same restrictions as if you're writing the code yourself. And so we actually can do things like generate equals hashcode and toString, even though the language otherwise offers that data modifier to do it for us. Because we're doing code generation, it's a lot easier to do the thing that's correct, even if it winds up producing more code, because you're not the one hand writing it.
Cool. So with that in mind, let's look at the next thing that Wire is generating, which is this builder class. So this is what we're going to be using to actually compose our type. One of the interesting and handy things about a builder class is that it can enforce restrictions on the type. So in this case, there are two things it's checking for, that the list we're passing in has non-null members inside of it, and that name is always non-null. So we're enforcing that it's always present. With Kotlin, again, you can move these sort of things into the type constructor itself with default values and name parameters, give you sort of a similar builder-like syntax. So we'll do that and switch it instead to have these default values. And this is enforcing the same thing that the builder was. But instead of doing it at runtime, now we're doing it at compile time. So our code's a little bit safer. Calling from Kotlin is still just as readable. You have these parameter names, and so that becomes part of the API. But it gets a little bit uglier from Java.
Yeah, so you wind up getting the linear combination of all the different constructors. But with the builder, we had the ability to specify whichever ones we wanted. And so we've lost the ability to have combinations which aren't generated in these overloads. But even if the constructor that you want is there, you've also lost a little bit of readability. And so we no longer know what parameters these values that are passing in are corresponding to. IntelliJ will help here because it has the parameter names. But for code review tools, it becomes less readable.
Yeah, so the default values and named parameters are sort of part of a larger story of Java interop, where when you're code genning, you sort of run into these problems. And you might be making compromises between, well, do I want to generate code that Java people are going to be consuming, Kotlin people, both? And in the last case, what you're probably going to want to do is continue having the builder, because using the constructor only from Java doesn't look quite as nice. So you might end up having both. But for Java interop, there are specific things that we want to call out that you should be aware of if you're doing code generation, in addition to like the default named parameters. So one of these things, going back a little bit, when we talked about naming the bean-style method, turning it into a field instead, so you can access it as a field. If these were instead abstract properties, such as on an interface, then you actually can't do this. There's no way to name these. And so you instead will always, from Java, be calling getLayer. So if you're building like a bring your own type code generation thing, then this is something that you have to be aware of.
So another interesting aspect of Java interop is with reified types. And this is extremely convenient because it allows the Kotlin calling code to not have to deal in actual class references. We can sort of specify the type in the call structure, and then the reification basically allows the code inside the function to use that type as if it were a class. But if we're using this code in both from Java and Kotlin, this actually isn't doable. The method that implements this becomes private, and so there's no way to pass a reified type or pass a type reference to this method. And so again, going back to the fact that this is code generation and you're not writing it yourself, if you need that interoperability story, just generate more code. You can generate the API that makes sense from Java and also the API that makes sense from Kotlin. And they even can refer to each other. So you can just have the reified version be a nicer syntax for Kotlin only and delegate all the actual implementation to the explicit class-based one.
So let's suppose that we want to be notified whenever Shrek's Swamp changes. Then if it's not reactive yet, then you're going to have to use some sort of listener interface. You've probably seen something like this before. Single abstract method, commonly known as like SAM methods. So when you want to add a listener in Java, you might use an inner anonymous class, but the language allows you to instead pass a lambda because this is a SAM. But if you want to do the same thing from Kotlin, you can't. You have to do this object. It sort of looks like the inner anonymous class that we had from Java before. And the correct thing to do from Kotlin is to instead just accept the lambda directly, which works great from Kotlin. But the problem with this is that from Java, we now have to return this unit type, which is another sort of thing that can get into the Java ecosystem if you're accepting a lambda in your Kotlin generated code. So it's something to be aware of. It might trick up people who aren't used to seeing this, especially if they haven't used Kotlin before. There is a workaround for this problem, which is to instead define your interface in Java. And now you'll be able to use a lambda from Kotlin, as well as using a lambda from Java.
Extension functions are a popular language feature, and if you're doing code generation, they certainly can allow the generated code to be more easily transitioned to from the code that you're manually writing. So in this example, we would potentially take any nullable reference and want to turn it into this optional type. Consuming this from Java is a little bit awkward, though. As a top-level function, it's going to be moved into a separate class with a name that actually reflects the file name that it's defined in. We can, of course, work around that with annotation and turn that separate class into something named more appropriately. And we can also change the name of the function itself to feel more correct for the calling style in Java. But the problem here is or a potential downside of this is that we're the ones defining both the optional type and this extension function. And so if we're defining the type and the function, why wouldn't we just have the function defined on the type itself? So instead of having a separate class in order to create these optional instances from Java, from the Java code, they can just call optional of nullable instead of having to know there's this second class. The problem here is that while this will work, and it does produce the correct thing from Java, our Kotlin code now suffers because the IDE actually currently is unable to autocomplete these extension functions referenced inside companion objects. And so again, there's kind of a workaround here. Same tricks over and over again, but if this is something that's being done in code generation, you should do the extra work and potentially expose it correctly in both situations by just having the static member on the optional class delegate to the extension function, or vice versa, actually. An interesting aspect of this is that from the Java side, you now have two ways to create these optionals. You have the class that's created from the file, and you have the optional class that's written. There's little tricks that can get rid of this. You can actually take the file class that's generated and give it a name that's invalid in Java source, but not invalid in Java bytecode by putting a dash in front of it. And so then the IDE won't actually be able to discover this second class.
And then finally, something to be aware of is the nothing type. If you're exposing the nothing type at all, just knowing what it's going to turn into on the Java side. So if you expose nothing on its own, it's going to turn into void. And if it's a parameterized type, then it just becomes the raw type. So your list of nothing in Java is just going to be a straight list. OK, up until now, we've been kind of talking about code generation of Kotlin in an abstract sense. And I want to talk about KotlinPoet, which is a library that we wrote at Square. And it's for simplifying the task of generating Kotlin code. The two things that come for free, or the motivating factors as to why you would want to use this library, is that it handles imports automatically. And it allows you to do nonlinear code generation, which means that you can create sort of functions and properties and arguments and all the shape of code you want to generate
in completely separate parts of the code generator, and then at the end combine them all together. So you're not generating a file as a string where you have to do it top to bottom. There's actual model objects. The fundamental key to using KotlinPoet is realizing how it represents types, because this is how you get the automatic imports and ensure that the generated code never references a class in a way that you don't expect, where it will accidentally resolve to the wrong thing. And so types ultimately exist in a hierarchy, and KotlinPoet models those types in the exact same hierarchy. And so classes make up a certain subset of all the representable types, and then you have like parameterized types, which are also types but make up a different subset. And to make these more concrete, you could think of like a string is your class, but a map of string to int is a parameterized type. And so there's types in KotlinPoet that model these. And if you're coming from just a normal class reference, extension functions are provided which turn that into what's called a class name, which is KotlinPoet's representation of a class. And the class name object itself doesn't really have anything to do with Kotlin. It just uses Kotlin to infer or to read the fully qualified class name. And so you don't need a K-class to create a class name. You can actually just use strings by supplying the package or the type if you want to refer to maybe a type that doesn't even exist yet. And so the reason we would want to do this is that if we model the string as one of KotlinPoet's types, class name in this case, when we do code generation and use this, it will automatically reference the type in the property as just the simple name, but it will omit the import for the fully qualified class name. And the nice thing about this is that KotlinPoet understands how type resolution works. And so if you have an adjacent class, which is a different string, this is still correct. It will pull the one that's coming from the import. But if you're generating a property inside of a class called string, KotlinPoet understands that it needs to omit the fully qualified reference here because you want to refer to the Kotlin platform type and not the type that you're inside of. And to go back to the example, you can create these parameterized names. And then nullability is a big part of the Kotlin type system. And so nullability is also modeled in the KotlinPoet type system. And so once you have these types, you can start creating the actual constructs of Kotlin. And so here we're creating that property I showed before. I want to point out, though, that there are a lot of convenience functions in KotlinPoet. So most of the time where you normally would accept that class name abstraction, we actually provide overloads so that you can just pass string.class, or if you're in Java, you can pass a Java class reference. And so a lot of times you actually don't have to create those type wrappers. The overloads will do that for you. But it's important to know that you need to be using these type references and not just emitting like string as a string. The other thing to look at is KotlinPoet only models the higher level constructs of the language, the functions, the properties, the types. It doesn't actually model what's inside of a function body, any code, or what's inside this initializer. It does provide a few helpers, though. You can see here we're using a sort of string format syntax. And the reason we do this is that when this code gets generated, KotlinPoet will automatically take that foo string and wrap it in quotes so that it's being generated as a string instead of just generating foo. And the reason you would want to do this is that if you're pulling this string from something like a YAML file or a Swagger definition, and there's a tab character, or there's a new line, or there's an unprintable character, KotlinPoet will automatically escape that in the generated code so that the value in the code that's being generated is the same value that was in the code doing the generation. And so here you'll notice I'm calling printline on this object, and it's printing out the fully qualified class name of the property. But I just got done telling you how imports are handled automatically and generated. And the reason for that is that this model object represents just a property. And if you think about just a property, there's nowhere to put imports. And so the only way that imports actually get included in the output is if you wrap these objects into a file spec, which is the top level model object for representing a Kotlin file. And so in a file, there's a place for imports. And so once you actually wrap these types into the final file spec where they're all coalesced together, you get the automatic importing. And so for the rest of this section, I'm just going to assume that we're inside a file spec. But remember that you have to always be wrapping these types inside of one in order to get things like the imports. So we covered property spec, which is for defining properties. We, of course, have one for defining functions. Give it a name, parameters. You can include the body. We can generate types themselves. And an interesting aspect of this is that KotlinPoet actually doesn't necessarily generate code that always will compile.
Yeah, and that was like an important philosophical decision. We instead decide to rely on Kotlin C, the compiler. So we'll always generate something, but if it's invalid code, Kotlin will fail, and for us, that's fine. We'll just rely on that. So if we wanted to make this data class actually work, we need to give it a property. So first we have to give it the property spec that Jake was going on over earlier. But this still isn't what we want. We still need the constructor parameter. So again, there's an API for adding that in. And this constructor parameter and the property need to be linked together through initialization. And only at this step do we actually turn it into a constructor property. And this is another philosophical decision we made with KotlinPoet, is that you're always going to be writing the code that you want. And if there are optimizations that KotlinPoet can make, like putting this into the actual constructor, then we're going to do that for you. You're not going to write it explicitly. One of the nice side effects of this is that if you wanted to change how initialization was done, so in this case, we're no longer just setting it to what was in the constructor. It's really easy to make that change in the KotlinPoet side. And the generated code, even though it might have a larger change signature, it was really easy for you to make the change in the actual code generation.
So we see this same behavior of KotlinPoet helping you out in expression bodies. So here we have a function which is an extension function, and it just has a single statement which begins with return. And so what KotlinPoet sees is that the body of this function only has a single statement. It starts with return, and so it knows that it can collapse that into an expression body that just has the equal sign. Now, if you were to come back later and add a second statement, something to say validate that the value you're converting is always greater than 0, KotlinPoet will undo that sugaring. It will desugar it into the full function body for you. And so you don't have to change the way that you're generating code based on if you want an expression body, if you don't want an expression body, if you want the constructor property syntax or the separate property and constructor syntax. It just happens automatically, and you generate, you tell KotlinPoet to generate the full thing, and if there are any optimizations that can be made, it will take care of it.
Yeah, so one of the other nice things about KotlinPoet is that you can take these fun specs and start using them over and over again. So if you wanted to refer to this method multiple times later in your code, then you can do that, again, by storing it in this long seconds field and then referring it to it later. You can see that here. And again, we're using that same sort of almost string format like templating, where we do the %n to refer to the name of this function, which in this case is seconds. And so in the generated code, you can see we're now referring to it the same way as seconds. And the nice thing about this is that if we ever were to change the name of this method, we only have to do it in one spot. We're doing it where we actually declared the fun spec. And then when we start reusing it over and over again, it's going to use the new change to name. So it makes refactoring a little bit easier.
Up until now, we've been showing APIs like add statement, which is where you include code that you want to generate. And that's basically just a helper method around this thing called a CodeBlock. And a CodeBlock is a representation of the interesting bits of code that happen inside your functions or maybe in an initializer for a property. And so we have that same add statement on CodeBlock. And you can see here there's another helper, %t, which emits a reference to a type. And again, this is one of the things that will handle imports automatically. So you would never want to put int.min value inside the string. You would put that replacement or that placeholder for the type and then refer to the actual class, because this is how you get automatic imports. And what's nice about CodeBlock is that you can use it to incrementally, it doesn't have to be a full statement every time you add something to it. You can have partial statements that you build up and use things like control flow inside your code generator to build up a single statement. Additionally, there's helpers for generating control flow in the generated code. And what's nice about this is it will automatically handle things like curly braces. It'll automatically indent the statements that are inside control flow. And so it just greatly simplifies generating those types of constructs. These code blocks, again, don't have to represent something that is a full statement. It doesn't even have to be something that compiles. In this case, I'm just pulling some individual references and coalescing them into a list. And so you can think of this like maybe you're in an annotation processor iterating over the parameters of a method that's annotated and pulling them into individual code blocks, which you put in a list. And then say you want to generate code which calls that method and uses these parameters. There's a lot of familiar methods similar to those in the Kotlin standard library for these code blocks. And so we can take these and join them together into a nice, simple reference to a method with all of these individual parts of an expression joined together with a comma.
Yeah, so Kotlin is a very feature-rich language, and we've sort of only been going over very basic stuff, but of course you can get really complicated with it. So does Kotlin handle this extremely, or KotlinPoet, does it handle this extremely convoluted method if I wanted to generate it with KotlinPoet? It does. And when we went over these slides yesterday, I mentioned to Jake, I don't think you can actually name a Lambda parameter. And turns out you couldn't, so we made an issue on GitHub. And then I woke up this morning, and Igor, one of the maintainers, had already made a PR fixing it. So if you do find a problem with KotlinPoet, we have like a very active maintenance for the code base. But yeah, so even something this complicated becomes pretty easy when you're doing it from KotlinPoet.
OK, Kotlin code is obviously easily consumed by Kotlin itself. But when we start getting into interoperability, there's a few other options that we can take. And so if you think about Java code generation, which is something that's done quite frequently nowadays, it's still worth keeping what that Java code feels like from the Kotlin side in mind. And so in this case, we have a method that's annotated with @nullable, indicating that it could potentially return null. And then when consuming it from Kotlin, we get the nullable type in the type system. And because it's named like a Java bean with the get prefix and a capital, it turns into a lowercase property. And so far, we've talked about KotlinPoet as some build step that you use to generate Kotlin code, which then is compiled into Java bytecode. Or potentially, you're generating Java code, which has some of these annotations or naming conventions that Kotlin understands and is also compiled into bytecode. But there's a third option, which is we actually could skip the language altogether and go directly to the class file format with bytecodes. And there's tools that already do this for you.
Yeah, so we'll go a little bit into that. And this is going to start to get a little bit technical. We're going to be going into the JVM bytecode. So we'll start from the bottom up instead of trying to generate bytecode. We're first going to look at the bytecode to see what things we might need to generate. So to start, we're going to go back to this example where I have an interface with a single abstract property. If you remember before, the bytecode has a method getBar instead of just bar because the getter backing the property is called getBar from Java or in the bytecode. So from IntelliJ, you can inspect, or you can, I think it's show Kotlin bytecode is the action if you Control-Shift-A for it. And it'll give you something like this, so you can start to actually look at the bytecode. And the thing that we really care about here is this Kotlin metadata annotation, which is the thing that really powers Kotlin. So all of your things like nullability, named parameters, they're going to be stored here so that the Kotlin compiler, when it starts compiling code, knows if something is going to be nullable or if it should be interpreted as a property in this case. If you're interested in more deep dive on the metadata annotation, Eugenio Marletti gave a really great talk at Kotlin Berlin Night where he goes into it. So I'd highly suggest watching that if you're more interested in what's actually stored in this annotation and how it's used internally. He also wrote a library for parsing it, so we're going to do that ourselves. The big thing to see here is that when you're parsing the metadata annotation, what Kotlin does is turn it into this proto class. And so similar to before where we had a proto for your ogre, there's another proto inside of Kotlin, which is all of this information. And so that's going to be a lot easier to read than trying to go through the actual metadata annotation in bytecode. So we'll do that, and then we'll inspect it to see what's actually stored in this proto class, to sort of figure out what's going on with this property bean method. So the first thing that you'll find inside of this proto is this list of strings. And what this is it's just a list of strings that are going to be referred to later in the proto. So when we start looking deeper into the proto to try and find our property, you see there is a property in the proto, and it has this name field where the value is an index into that string array that we had from before. So the name of this property is index2, which if we go back to the array of strings is bar, which makes sense because our property is called bar. The next thing we want to find is the actual getter method that backs the property. So again, you can go into the proto, find this getter proto, and it also has a name, but this time it's index 4. So if we go back to the string array and look back at index 4, it's getBar, which makes sense because that's what it's going to be called by in Java. So if you look back into the actual class file, these are sort of the two things that we care about. This getBar in the string array, as well as getBar in the actual bytecode method, are the two things that are making the Java code call it as getBar. And then the metadata annotation is the thing that's making it so when you call it from Kotlin, it's calling it as a property. So if we wanted to generate this bytecode ourselves and this metadata annotation ourselves, we need a new tool. And we're going to be using something called ASM. It's what Kotlin also uses internally. And one of the great things about ASM is it works both ways. So you can feed ASM bytecode, and it will emit the Java code that you need to run to generate that bytecode. And then it works the other way around, again, since it's giving you back that Java code when you feed it the class file. So we'll start with that. We will take our class file, and we'll feed it into ASM. And then it's going to give us back this list of method calls that is going to generate the class file for us. And I've only included a subset here. There's a lot of other stuff that's going on. But these are sort of the two pieces that we cared about, right? The string array as well as the method. So theoretically, if we wanted to change the name of the method, those are the two things that we would have to change. We could change them from getBar to bar. One thing I really want to note is don't do this. This is a really bad idea if you're planning on writing metadata. What you should be doing is similar to how we deserialized the proto from the metadata annotation and then looked at it in Java. You should be doing the other way around, where you'd be making your changes to the proto and then serializing it back into the bytecode. But because this is a simple case, we're just going to do this for now. And we can feed it back. So now we run that code, and it's now going to generate for us a new class file, which hopefully the method is now backing the property is going to be called bar instead of getBar. And it works. You can compile with this. And now instead of having to implement a method called getBar on your subclass, you can just implement the method bar.
So there's other reasons why you might want to dive into manipulating these metadata. And one reason is that you may already have a Java SDK. Here we have an example of a method from a popular SDK used on a popular mobile platform. But it's actually a really poor method, right? It's got these single letter parameter names, and you have to remember the exact order in which you want to pass things in. And currently from Kotlin, we have to call this in the exact same way that we would in Java, and we don't get any of the nice features of the language in using these methods. Well, if you were able to take the class file that's the result of compiling this plain Java method and add this metadata annotation to it, you can contribute things like default parameters, default values, or named parameters. And that would allow you to change the Kotlin calling convention to feel more idiomatic by using those language features. And you can do this without actually changing the Java source file or having to actually rewrite it in Kotlin. If you choose to do this, you have to be really careful because both default values and named parameters become part of the public API, and you have to commit to them because then changing them would break people who are calling from this style.
Yeah, so it's a lot of different ways of accomplishing the same task, which is getting this JVM bytecode that you're going to be able to write Kotlin Java code against. So you might be wondering, is there a reason that I should specifically be using Kotlin and KotlinPoet to generate Kotlin code? The big one that we think you should be doing it for is multi-platform support. So we've only been talking about so far targeting the JVM and generating these Kotlin files that are going to be used on the JVM. But the same code generation could be used to target JavaScript as well as native. And so if you start to enable this, it means that the people who are consuming your code generation can be iOS developers, or they could be JavaScript developers. So all of a sudden, your library becomes a lot more useful and potentially has more utility.
So the most important thing for multi-platform code generation is avoiding anything platform-specific. And so KotlinPoet currently only runs on the JVM. And so because of that, the code that uses it also can only run on the JVM. And because we use class references in your generating code, it's very easy to accidentally slip in types that you're comfortable using on the JVM. But in your generated code, you've now emitted a platform-specific reference accidentally, and so a Kotlin user on JavaScript or a Kotlin user targeting native would be unable to use your tool because this won't compile. And so in this case, you have to prefer Kotlin's native version of creating a set. And so you don't entirely have to avoid platform types. You just have to avoid generating them by default. So for another example, if you're generating code from other code, and the user who wrote the original code references a platform type, then your code can safely assume that it's running on that platform and reuse that type reference in the generated code. So by virtue of my ability to compile the top code, which references Guava's immutable list, I myself as the code generator can safely assume that if I generate a reference to it, it will also compile. But you might not be using a code source as from which you're generating. So in this case, we have a SQLDelight where we allow you to specify an additional type that you want to project a column into when you're referencing generated bindings. And again, by virtue of the fact that the user specified this type, as the code generator, I can then assume that it's going to be present and generate that version of the code. Another interesting thing about multi-platform is, and going back to what I said before about making an API feel idiomatic based on whether you're calling it from Kotlin or calling it from Java, is you don't know the platform to which your user is going to be consuming the generated code. And so you can do things like include platform-specific annotations in your multi-platform code. And this makes various things feel more idiomatic based on the normal conventions of that language. So in Java, we might want to have a different named method because we have a different calling convention. The problem here is that using these platform-specific annotations actually currently doesn't work. But the Java ones are available in the common standard library of Kotlin, but when you go to actually convert it to JavaScript, the annotations are there, but they're marked as internal, and so the code won't actually compile. And similarly, if you want to control the naming as to the conversion to JavaScript, this annotation actually doesn't exist at all in the common standard library. It only exists in the JavaScript specific one. And if you haven't noticed, by the way, in the bottom right-hand corner, we've included a couple references to bugs that are filed to fix these things. And so hopefully in the future, some of these things actually won't be limitations, and you can leverage them in your multi-platform code.
Cool. So let's summarize and go over some of the biggest points that we want people to come away from this talk with. The first one is that while you're code generating, verbosity is OK. The API is what's important. So if you're generating the equals toString and hashcode methods, that's fine. For code generation, it's going to run just as quickly. And making a change where you're like adding a new property, you're not going to have to change it in every location because you already wrote code generation for it. So it's OK to have extra code if it means that your API is going to be nicer and sometimes more consistent between Kotlin and Java. The second thing is that if you do any Java code gen, you should still be keeping Kotlin in mind. And this is also true for bytecode. So if you already have a bytecode transformer, then the metadata annotation is something that you should be keeping in the back of your head, and just Kotlin support in general. And the third thing is that don't depend on platform types unless the user does. This one is pretty self-explanatory. It just means that when you're targeting multi-platform, you don't have to worry about these cases where you no longer can. So as long as the user is the only one who's supplying these platform types, you'll be fine. So even if you're not directly targeting multi-platform from day one, this is just a good coding style because it means that if at some point in the future you want to, you'll be able to easily.
So just today, we released a new version of KotlinPoet. It's not at a 1.0 yet, and so we're constantly changing the API to make it be able to produce all the different constructs that Kotlin has. And I mentioned that KotlinPoet is currently only able to run on the JVM. We use and reference things specifically in the JDK. But in the future, we actually hope to break those out into platform-specific versions. And so if you want to write a code generator that maybe your JavaScript developers can consume and actually run on Node.js instead of running a JVM, or you actually want to run it as part of a native toolchain instead of a JVM, that you'll be able to use KotlinPoet and have your code generator potentially be multi-platform as well. So we're still looking for things that are wrong in KotlinPoet and things that are missing. The biggest thing right now is the API feels very Java-y. We have a library called JavaPoet as well, which is for generating Java code, and KotlinPoet was created from JavaPoet, and so the APIs are very similar. Eventually, we hope to turn it into more of a DSL, so there's a little bit less of the verbosity for code generation. But that's not really the most important thing, because again, in a code generator, you can pay that additional cost of doing the work so that your user, that your consumer of the generated code doesn't have to. And so we'd love for you to give this a try and see what's missing and tell us about any use cases that we otherwise haven't thought of yet. And that's all we have.
Sweet.
Thank you.
Thanks.